Be that much easier. So we know that cosine is x, sine is y on our unit circle. So if I said find the cosine at pi hash, you would say 0, correct? If I said find the sine at pi hash, you would say 1. Correct, everybody. Tangent is easy. It's just sine over cosine. So I'm going to write that down. You should write it down too. So I'm going to do it in red. So tangent is sine over cosine. Sine theta over cosine of theta. So really, if you think about it, that would mean that on our unit circle, since sine is our y value, we would be doing tangent of theta will be our y value divided by our x value. And that's how you find tangent. So it's super easy, just one extra step. So let's do an example here. I'm telling you to find the tangent at pi force. So everybody, you'll locate pi force on your unit circle and you would say these are an xy point. Tangent's just our y value divided by our x value. So right here we would do root 2 over 2, which is our y value, divided by our x value, which is root 2 over 2. What does that simplify to be? Anything divided by itself is 1. Very good. So tangent at pi force equals 1. Pretty easy stuff. However, it's not, I mean, the algebra was easy on this one because it just divided out to be 1. At 30 degrees, it's going to be just a teeny bit harder, only the algebra. So let's do another one. Tangent at 30 degrees. So you'll go to 30 degrees. Tangent is y divided by x. So at 30 degrees, it would be 1/2 divided by root 3 over 2. And then you'd have to say to yourself, okay, dividing fractions is easy as pie. We flip the second fraction and we multiply. So now to simplify that, we would take and multiply by, flip the second, that'd be 2 over root 3. So now think about it. Don't those 2's divide out? Right? So that'd be 1 over root 3. We'd have to do this by hand. Is that an appropriate answer? No. You guys see, you guys are advanced thinkers. You're able to see right away that answer is not acceptable. What do I need to do to it? Good. Multiply by the root 3. What we're doing is rationalizing the denominator. So we're going to say that is my answer, but I just got to simplify it. So we'll multiply by root 3 over root 3. So that comes out to be root 3 divided by root 9. Which equals root 3 over 3, correct? So that would be our answer at 30 degrees for tangent. So you just did y divided by x and then it was just algebra. So how about you guys give it a try? Do those two. Ready, set, go. You can do it on a whiteboard. Give it a try. There will be a tangent one, hopefully, on the test. That's your word. Should be positive because a negative divided by a negative. I messed that up originally. A negative divided by a negative there. Good job. Okay, did we get root 3 on the first one? Okay, good. And just the evidence, watch, because I originally didn't pay close enough attention and didn't remember on this one, there was 2 negatives divided, which made it a positive. So we wouldn't need to write positive. I just did because I wrote negative on accident. Then on tangent at negative pi half.
Isn't it 10th day already?
Yeah. Yeah, it really was, actually. That's funny. Okay, so right here we have negative pi halves. And that was negative 1 divided by 0, and you'd say, oh, we can't divide by 0, so it's undefined. All good? Okay, sweet. Okay, now let's extend our knowledge even a little bit further. So let's now learn how to do cosecant at 2 pi thirds. So that's actually really easy. Cosecant is just the reciprocal of sine. So that reciprocal means you just flip sine. No, yeah, sine. So remember that cosecant is just the reciprocal of sine. So that means you can literally, so cosecant at 2 pi thirds, let's all locate 2 pi thirds. Let's write down what sine is at 2 pi thirds. So sine at 2 pi thirds is our y value, which is root 3 over 2. So we have the sine. But now cosecant just means the reciprocal of that. That's what cosecant means. It's 1 over that, or just reciprocate it. So flip it to get cosecant. So wouldn't that be 2 over root 3? Yes. And then is that answer acceptable? No. So we would rationalize the denominator from there. So multiply by root 3, root 3. So on top we would have 2 root 3 over 3. That would be cosecant at 2 pi thirds. So you just find sine, reciprocate it, and simplify. So let's do secant. Secant is the reciprocal of cosine. So let's list out what cosine at negative pi fourths is. Remember, positive pi fourths is here, so negative pi fourths will be here. Cosine is our x value, so root 2 over 2. And you'd say, but I'm not finding cosine, I'm finding the reciprocal, which is secant. So we'd flip it, so 2 over root 2, and then wouldn't we rationalize? So we'd multiply by root 2, so on top we'd get 2 root 2 over 2, which is root 2. Can you guys try some by yourself? Okay, awesome. Go for those two. Cosecant at 7 pi 6. My handwriting looks terrible over there. Cosecant at 7 pi 6 and secant at 7 pi 6. How many got them right? Awesome. Nice. Okay, good. Awesome. Okay, let's get to today's lesson. That was just a building. Let's build on your knowledge a little bit. Very good. All right. So last time we learned how to find, so we've known in the past, we've learned to find missing sides and missing angles of right triangles. That's called right triangle trig. Those ones are really easy. You set up sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. However, when we have non-right triangles, we still need to be able to find missing side lengths and missing angles. And that's how we were introduced to the law of sines. So the law of sines, remember, was sine of, let's see if I can get a blank page. Okay, remember that the law of sines was sine of angle A, and I'm going to draw this in because I feel like I explained it better to other hours. So sine of an angle divided by the side across from it will be equal to sine of this angle divided by the side across from it, which will be equal to sine of that angle divided by the side across from it. Now it has to be in that order. It has to be sine of the angle divided by the side across from it. You can't jump around all over on the triangle. And then remember, we can actually do, so if we were trying to find angle A, we would start with sine of x. Like for example, sine of A over the side across from it. Anytime we're trying to find something, I like to put it on top. So let's say instead we were trying to find side A, we'd put A on top over sine of whatever angle A is. Does that make sense, everybody? Because people were like having a hard time with where do I put first? Always put the unknown first and then go from there. So we use the law of sines when we can. So when we have two angles and a side across from one of the given angles, we can then find the third angle and we can find the missing sides, setting up the law of sines. Also, we use the law of sines if we're given an angle and a side across from it, and then one other side. Then we can find missing angles. Then once we know that angle, we can find that angle, right? And then we can find the other side using the law of sines. So we could solve this triangle by a law of sines. However, we can't always use the law of sines. Unless you have it in that particular order, you have to use the law of cosines. So what I want you to do right now is see if as a group you can do this problem. It is using the law of sines. So let's give it a try. Let's see if you can remember what we learned last time and apply it in a real world problem. But I drew a picture for you. So ready, set, go. Try it. Like, we have plenty of time today, so see if you can do this one. It's not on your worksheet. You're just putting it on a whiteboard. So now let's say we can't use the law of sines. Then we revert to the law of cosines. So start writing down the law of cosines. So here's the thing. People write down the law of cosines like this, but what's hard is it's all interchangeable. So I think of it like this, and then I don't have to think about, oh, like it's A, B, okay? So the law of cosines you can solve, if you can't use the law of sines, you can use the law of cosines. So the law of cosines is a squared will be equal to b squared plus c squared minus 2 times b times c times cosine of angle A. And I'll explain in a second. So I like to think of it like this instead. Side 1 squared will equal side 2 squared plus side 3 squared minus 2 times side 2 times side 3 times cosine of angle 1. I know. I'll give you a second to write it down, and then I'll give you some hints and stuff of how this will work. Okay, so whenever we're trying to find, it goes on the outskirts of town. So for example, if you're trying to find a side, that's what you put here. So like x squared, like we don't know that side. So anytime you're trying to find a side, that's what's going to come here. Then you'll be given the other two sides. So you'll just use, it doesn't matter the order, the other side plus the other side. So what I want you to notice is it's this side squared equals, so side 1 squared equals side 2 plus side 3 squared. You see how they're each squared? And it's minus 2 times that times that. You see that? So do you get what I'm saying? Minus 2 times that times that. So just a little pattern. And then it's cosine of the angle that's going to be across from the missing side. So these go hand in hand. This is the angle across from the missing side. So, I mean, there is a little bit of memorization involved, but if you notice the pattern, it'll be this side squared equals this side the other side squared plus the other side squared minus 2 times that times cosine of the angle that's across from the missing side. Now, if you're trying to find the missing angle, you'll be given all three sides. So, if you're trying to find angle A, then side A has to be on the outside, because these go hand in hand. Does that make sense, everybody? So that's how you know why to put that one out on the outside. Once we do a couple examples, you'll start seeing the pattern, and I promise it'll be easier to memorize. So you would use the law of cosines if you have three sides and no angles. You might want to write this down, but really, it's hard to remember all this. So what I always end up doing is I look at a triangle and say, can I use the law of sines? And then if I can, I go for it. And then if not, if I'm like, nope, not enough information, so it must be the law of cosines. So we use the law of cosines if you have three sides and no angles. This allows you to still find the angle. Not always. So you might be given three sides and then you can find any angle you want. You'll see what I mean. It's not bad. It's all just algebra after this. It's really not as bad as it looks, I promise. Some of my honor students like the law of cosines better than the law of sines. But to me, the law of sines is way easier. Yeah, and then also you can use the law of cosines if you have two sides and a given angle, where the given angle is across from the missing side. So if you're given an angle that's between two sides, then you don't know the side across from it. So you can, and then if you don't have any other angles, you can't set up the law of sines. So that's when you would use the law of cosines to find the missing side. You'll see once we do it, I promise. It's not as bad as it looks, really. Okay, we all good? Not yet. Okay, I even drew a picture for you. We would use the law of cosines here because you see how if I went to try to use the law of sines, so we're given three sides, I have like sine of this angle, let's call it angle A, sine of A over the side across from it, 24 equals, and let's call this angle B, for example, and you would say sine of B over the side across from it. Do you see how we have two unknowns? So then you say, oh, but I can actually solve for that angle, any angle I want, using the law of cosines. Now, we always tend to find the largest angle first. In fact, we should. So wouldn't we find angle B first? Because that's across from 25, which is the largest side. So that must be the largest angle. So we would just say, okay, we're going to find angle B first. Now, right here, if you try to set up the law of sines, notice we can find the area of this triangle. But if I said to you, find this side, if you tried to set up the law of sines, you would say, okay, cool. So you would do you would do x, because we'll call this x. So you would do x over sine of 34, which everything's good so far, equals And then like, for example, 15 over sine of, well, yikes, we don't know. Now look at our problem. We have two unknowns again. So you say, oh crap, we can't use the law of sines. Let's revert to the law of cosine. Here we go. Number one, it says find angle A, or sorry, find side AB. So I'll just put an X there. Find side AB. So notice we're dealing with two sides and an angle. We could find the area, but I'm asking you to find the side. So this is what we're going to do. We're going to say you have your law of cosines. You'd say, okay, so we're trying to find this side x. So the side has to go on the outside, what we're trying to find. So we'll put x squared. This side squared equals one of the other side squared. So I'll just go 15. 15 squared plus the other side squared plus 7 squared. Then it's minus 2 times that, always. So minus 2 times this side, times by cosine, is the law of cosines, of the angle that's across from x. So let's locate x. The angle across from it is 34, so that has to be cosine of 34. Now look at my formula. It's all good. Over here, there's no unknowns. So now it's just all typing it into your calculator. So we have x squared equals what? Let's all type it in. Now we need to write down the full decimal here. So because this isn't our final answer, so we cannot round to our final answer. 99.90210,976. Now last step, very good. Square root both sides of the equation. So square root. So you'll type in second square root of second answer because I don't want to have to retype in the decimal. Remember how your calculator can retype that in for you. So x is equal to 9.99. We would show our work, which in our directions it says round to the nearest tenth. Because this is rounding up, it's going to round to be 10. So this side is 10 meters. And we're done. Not bad. Now understand, if I said to you, now finish finding the angles, now we would set up the law of sines. So I just want to extend your knowledge because on the test I might just say solve the triangle. That means solve it completely. So now we can find angle B by doing sine of angle B over the side across from it, 7, equals sine of angle B over the side across from it equals, let's use this angle, right? We need to use this side. So sine of 34 over the side across from that, which is 10. And now we can solve for angle B. And then once we know angle B, we can do 180 minus that minus angle B to get angle A. Does that make sense, everybody? Okay, awesome. Let's do another one. Number 2. It says find side BC. So let's put our X right there. And you would say, okay, I can't use the law of sines because I don't have another angle to like set up a true good statement here. So we're going to use the law of cosine. So x is going to go on the outside. Side squared equals one of the other side squared, 11 squared, plus the other side squared, 18 squared, minus 2 times that, it's always that, times by cosine of the angle that's across from the missing side. So cosine of 102 degrees. And now we're just doing the same exact thing. Again, remember that we would need to put in, we would be showing our work for the test. It's just worth it. Oops, I didn't mean to put a decimal there. Just ignore that. So that's not that. Well, I'm going to rewrite it. That's going to bug. 3330296. Then you would square root both sides of the equation. 22.96. So then you would show that since we're rounding to the nearest tenth, that happened to round up to 23 yards. Okay, awesome. Any questions? Are you guys good with that? Okay, cool. So now let's do one that requires us to find an angle. So everybody, we're going to go to number 7. It says find the measure of angle B. Now notice we're not given any angles here, so there's no way to set up the law of sines. So everybody, let's put an X at angle B. Sure, why not? Because that's what we're trying to find. We can't set up the law of sines, so you'd say, dang nabbit, I've got to use the law of cosines, and our algebra is going to be a little different here. Now this is important. You have to do the stuff that's missing on the outskirts of town. So isn't this the side across from the missing angle? That's what has to come first then. We're going to have cosine of x, so on the outskirts of town has to be that side. So we're going to put 28 squared equals the other side squared, so 12 squared plus the other side squared, which is 18 squared, minus 2 times 12 times 18, just like before, times that, times cosine of angle x. Now, our algebra here is just a little bit trickier. I mean, now look, there's only one unknown, but you are going to want to show your work because it's really easy to type in and get something wrong. So what you're actually going to want to do, it's just worth it to get it right. Like actually kind of calculate it in pieces because you have to think about rules of algebra. For example, people start to do weird things like, I'll explain in a minute, but let's just start going for it. So 28 squared is 784. Just show your work or else your algebra will most likely come out wrong. Now we have 12 squared. Can't we add those two together? Yeah, right? But we can't combine it with the minus 2 times 12. Like people will subtract 2, then times by 12, then times by 18. That doesn't work. You can't do that. So, but we can add those two together. So 12 squared plus 18 squared is 468. So I just simplified that. Now you can't subtract 2, then times by 12, times by 18, because multiplication comes first. So I want you to actually multiply those together. Negative 2 times 12 times 18. So they have minus 432. That became 432, negative 432. And then we have cosine of x. So I want to warn you of something. What I have students do that are advanced algebra people, they'll put those together, but we can't. Isn't that connected to cosine? You can't combine those. Do you understand that? You can't combine those. Does everybody understand? So now you're saying, what's my goal? My goal is to get x alone. So my first step is to subtract this 468 over to both sides of the equation. Do not combine those two, you can't. But we're trying to get x alone, that's our goal. So we'll subtract 468 from both sides of the equation. So then we have 784 minus 468 is 316, which equals, so those went away, we have negative 432 cosine of x. Now you're using algebra to get x alone, so what's my next step now? Yeah, we're going to divide both sides, you're awesome, of the equation by negative 432. Divide by negative 432. So then you could even do a simplified fraction if you were being really, if you wanted to really show your work. So math enter. So this is really negative 79 over 108, which you wouldn't have to do a simplified fraction. That equals cosine of x. And now we have one last step to get x alone. Inverse cosine, not to be mistaken with secant, that's not an inverse. So we're going to inverse cosine both sides. So cosine inverse, you got to do it over here, cosine inverse. And remember when you take an inverse, it entraps that, right? Cosine inverse undoes cosine. So x is equal to cosine inverse of negative 79 divided by 108. And now you'll type it into your calculator.
Yeah.
Okay, perfect. That's right. X is equal to 137.01. And that was a side link. No, that was in degree, sorry. That was an angle. So that angle was 137.01, which makes sense. Look at it. It's obtuse. That was a great angle. So we found angle B. All good? Okay. Maybe one more like that, and then the rest of the worksheet's all you. One more maybe? Okay. Number 8. Find the measure of angle A. So once again, notice there's no angle, so we can't set up the law of sines, which is quicker. So, but dang it, we have to use the law of cosine. So I'll just put my x degrees there. And then remember, the side across from it has to go on the outside. So we would say 24 squared equals 19 squared plus the other side squared, 25 squared. No, but you know what? No. You'll always put what you're trying to find, the side across from what you're trying to find on the outside. Yeah, good question. Minus 2 times 19 times 25 times by cosine of angle x, which is really angle A. So you could even just write cosine of A Now it's just algebra, but once again, you go through the algebra by yourself and make sure you can do it, because people start to try to do it all and they mess up on their algebra because they get lazy and don't want to have to write out their work. But to me, it's always worth it just to get it right, because it's worse to have to go figure out, what did I type in wrong? What did I do? Yeah. And then look at what I'm looking at here. This is what I'm looking at, and then I would not make the tragic mistake of combining those 900s, because you can't, because it's connected to cosine by multiplication. We will see if that is right. So that was 64.4 degrees. Questions on that? 64.4 degrees? Okay. The rest of the time is yours. So you can use the law of cosines, and if not, use the law of sines. I would try to use the law of sines first, but then if not, use the law of cosines. So that first page is all the law of cosines.